Hello, everybody, and welcome to another day of math. You guys are having a blast with it, I'm sure, right? Hey, on the bright side, you guys can, wear a hat. It's online school. You can do that. Nobody's going to tell you to take it off. Okay, so today we're going to talk about perpendicular lines through a point. Perpendicular through a point. Okay, so this is on page 63, so turn to page 63 in your book, and I'm going to give you guys some notes just real quick here. Okay, now what's going to happen is they're going to give us an equation for a line. So let's say y equals 1 over 2x plus 4. Okay, and they're going to want us to, and they're going to also give us a point. Sorry, they're going to give us a point. So let's say 2, 4. Okay, it's a tough one. So they're going to want us to create a perpendicular line to this equation. So remember, here's my original line. A perpendicular line would intersect it at exactly 90 degrees, right? It's kind of the opposite version of that line. If it was a positive slope, it's a negative slope, and then, all the different things that are perpendicular. So remember, perpendicular slopes is when you have the opposite reciprocal. So that is, so example, if I had like 3 over 5, its opposite reciprocal would be 5 over 3, but negative, right? So the fraction flips and changes signs. So to draw a perpendicular, or to create a perpendicular equation that goes through this specific point, I need a specific perpendicular line. Not just anyone, so I can't just change the slope. I have to do some stuff, just like we did with parallel lines. I have to find a y-intercept, basically. So the very first thing I'm going to do is set up the perpendicular equation. Okay, so to set up the perpendicular equation, I know what the slope's going to be, right? It's going to be the perpendicular slope to 1 over 2. I don't know the y-intercept. So just like what we did with parallel, I'm going to take out this plus 4 and just replace it with a plus b, a generic, like, I have no idea what you are kind of thing. So to create the perpendicular equation, it's going to be y equals the opposite reciprocal of 1 over 2. If you flip 1 over 2, it would become 2 over 1, right? But you have to change the sign as well. So the opposite reciprocal would be negative 2. So it would be negative 2x and then plus b. I don't know what you are, y-intercept. I got to figure you out. So now I have my perpendicular equation set up. Now I plug in my points. This is the x coordinate. This is the y coordinate, right? They would replace the x and y in your equation. So y would become 4. X would become 2. So I'd have negative 2 times 2 plus b. Now this is basically a two-step equation, right? I would multiply the negative 2 by the 2, which would give me negative 4 plus b is equal to 4. And then to get the b by itself, I would add 4, which tells me that the b is going to equal 8. So now the last step is I'm going to come back up to this original equation, and I'm going to replace that b with 8. So my final answer would be y equals negative 2x plus 8. And that's it. It's not too bad, right? Again, it's just kind of substituting in some things for x and y, and then you have to change the slope before you start. Okay? Biggest mistake students make is they like to hang on to this original y-intercept. Do not hang on to this original y-intercept. It's gone. You don't know what the y-intercept is, so you're just replacing that with b when you set up your original perpendicular equation. One other thing before I move on is, let's say I have one of our special cases. So let's say I have y equals 4. Okay? And I want a perpendicular line that goes through the point let's say 3, 7. Okay, now remember y equals 4 is your horizontal line, right? It's going to be that type of line. Something that's perpendicular to it would be the vertical line, right? So it would be an x equals, the vertical is x equals some number, right? Well, since I know that I'm going to need an x equals equation, I'm going to look at this point, and now I've told students in the past to graph it, to try to visualize it and stuff like that, but it's much simpler than that. If it's x equals, that means it only has one x coordinate, the whole line, right? The y's are all going to be different. But if every point on that line has the same x coordinate, it's just going to be the x coordinate in the point that you're looking for, right? The perpendicular line to y equals 4 would be x equals 3. Because if it has to be a vertical line, then every x coordinate would need to be the same. If it needs to pass 3, 7, then that means that the x coordinate would need to be 3. So this would be your perpendicular line. You don't really need to do any math. You just have to recognize if it's x equals, you look at the x coordinate. If you're trying to write, if it had originally been an x equals and you're looking for a y, then you would have looked at the y coordinate. So it's really just that simple. Like whatever the corresponding coordinate is to whatever, variable you're looking for, that's what it's going to end up being. Okay, let's look at an example. Let's turn to page 65, or 66, sorry. We're going to start on 66. And let's do one of those. So let's look at number 10. So this gives me an x equals, right? So again, a perpendicular line would be a y equals. Okay, so since it's y equals, this is my point, -2, -4. Which one of those is the y coordinate? Well, it's -4, right? If it's y equals, every y coordinate is going to be the same on that line, right? So if it has to hit this point, that means that the y would have to equal -4. It's that hard. Okay. Let's do another one. So for the assignment today, I want you guys to just do these first 4 problems, so 9 through 12 on 66. And then on page 65, I want you guys to do number 1, 2, 6, 7. So basically everything that's in the slope-intercept form already. And I'll do one of these trickier ones with you. So let's do number 2 here. So I have y equals -8 over 3x plus 4. I'm going to set up my perpendicular equation. That was my first step, right? I didn't do a good job of completing my steps. Sorry, guys. I forgot I was doing that. Okay. First step is to set up your perpendicular equation. I'll do it now. So y equals, I'm going to flip the slope and change the sign. So instead of -8 over 3, it's going to be positive 3 over 8x and then plus b, because I do not know that y-intercept. Next step, if I had done this correctly the first time, would be to plug in x, the point, plug in point for x and y. Okay? So we're going to take our x coordinate, which is 2, replace the x, take the y coordinate, replace the y. So I'm going to get -2 is equal to 3 over 8 times 2 plus b. And we're going to deal with fractions, so hopefully you guys have a calculator that can do fractions. If not, there's all sorts of calculators online that you can Google or use your phone and stuff like that. Okay? But we're going to start by typing in 3 over 8 and timesing it by 2, which is 3/4. Okay? Now, that gives me 3 over 4 plus b equals -2. Sorry, keep forgetting to put my steps. Next step is to solve for b. Okay. And then the last step will be to replace b in perpendicular equation. Okay, so we're still solving for b, so it's a positive 3 over 4. So that means I got to subtract 3 over 4 to each side, so minus 3 over 4 to each side. So negative 2 minus 3 over 4 is negative 11 over 4. So the b is going to equal negative 11 over 4. So then I take this and I'm going to come back up here and I'm going to plug it in for the b in that perpendicular equation. That's my last step. So the last step there, I'm going to have y equals 3 over 8x minus 11 over 4. And that would be my answer. And that is how you set up a perpendicular line through a specific point.